Hello Legacy Sabers, Marsh here. So today we're going to look at graphing square roots and cube roots. What you're going to want to have on you today, that graph paper with the notes I gave you in class, pen or pencil, and then also a calculator today. So just a little bit of review of what we've already covered in our time together. So y equals x squared, if you remember the general shape of that, was the parabola. Absolute value was our v function, because remember, v for value. Y equals mx plus b, that's just the nice straight line. X cubed we just looked at, that was one that looked like that, right? And then x to the fourth, it did something kind of like this, whoop-de-whoop, kind of like a w, or it just did a normal parabola as well. So now we're going to look at the parent square root function. So these, you're going to basically have to generate a table. So normally, remember when we would generate a table, it would go -2, -1, 0, 1, and 2. So we got some negatives and some positives. But I can't do the square root of -2. That's imaginary. So can't do that one and can't do that. So every single one of your graphs is going to start at 0. So that's the only thing that 0 can be used for. So let's figure out our numbers over here. So I got the square root of 0, right? Well, that's just 0. So plug in my 1, the square root of 1, which is 1. Square root of 2, that's a decimal, but that's okay. You can graph decimals. So it'd be 1.414. And then the square root of 3 is 1.732. So if I graph that, I would graph something like this. So notice here how it starts at 0, 0. Then I have a point right here at 1, 1, and then at 2, kind of in the middle, right? And then 3 is kind of getting closer to 2, but not exactly on there. So all your graphs will look something like this. They'll kind of shoot off into the right-hand side. That means our domain, guys, notice how it's starting at 0. So my furthest x value would be 0, but I do go off to infinity this way, so it keeps going this way. Range, notice I don't go below here. I'm only starting at 0. So my range is 0, but I do go up forever. This is eventually going to keep gaining altitude, if you want to consider it that way. So it's going to continue to get higher. My range is going to keep, I'm going to keep getting to the higher y values, or the greater y values. Now, what you're going to want to be able to do, though, is think about how the thing is shifting and moving around. So remember, our x squared, it usually started at 0, 0. That's our parent function of x squared. If we had the -8 there, that went down 8, right? We would take it, you would take the entire parabola and go down 8 units on the y-axis. If there was a negative number in front, or a negative, remember that flipped our parabola, so instead of having an upwards u, we had a downwards u. And then remember, when something was inside the squared, if we were adding it, remember it was backwards. Do you remember that? It was backwards from what we thought. So we would have thought right 6, but remember, this said left 6. And then we had ones that had a bunch of stuff in it. So right here, this would mean right 4, and this meant up 5, right? So in this box here, this is what I kind of want you to have down. Remember, here would be our general form of our square root function. First thing is, if I have something on the outside of my square root, that is a vertical shift. Not shirt, that's just silly. Vertical shift up or down outside the main function. So you're going to want to make sure that that's outside the main function. The h, or something inside of the square root, with the x, so if it's a minus, it'd be right. If it's a plus, it'd be left inside it. Then if we had a negative on the outside, that made it flip in the front of the function. That made it reflect. And then if we had a number, that's just going to kind of stretch it or push it down, depending on what it kind of did. So these couple of things are going to give us an idea of what our graph is going to look like when we do our next two examples of square root functions. So, very first thing, guys, you know how we started at 0, 0 on our parent table? We need to figure out where we start. So I'm going to think of my shifting here. So I got x minus 3 plus 4. So this x minus 3, remember that's going to make us go right 3, and this is going to make us go up 4. So to find my starting point, because it's not at 0, 0 anymore, since it kind of shifted and moved my graph, let's follow my directions. So I'm going to go right 3, up 4. So that's actually going to be my starting point of my graph at the point 3, 4. So that's going to be the start of my table. Now let's put some numbers around there. Because remember, we can't go below, right? Because then we're going to get negatives, and calculators don't like negatives under square roots. So plug these into my function here. So I would get the square root of 4 minus 3 plus 4. Square root, or 4 minus 3 is 1. Square root of 1 is 1. So I got 1 plus 4. So my answer would be 5. Same thing here. 5 minus 3 plus 4. Well, square root of 5 minus 3, that's the square root of 2 plus 4. That is approximately 5.414. Something like that. I did that on my calculator. I did the square root of 2 plus 4, and I got my answer. Same thing with 6. Let's plug it in. So it'd be 6 minus 3 plus 4. And, well, 6 minus 3, that's the square root of 3, right? Plus 4. So this would be 5.732. So square root of 3 plus 4 is 5.732. Let's graph the rest of this. So 4, 5, 4, 5 right here, the dot, then 5, 5.44. So something like that, kind of close to the middle, but not exactly. And then 6, 5.37, kind of close there. So it's going to be a graph. It's going to look something like that. It's going to shoot off into the sunset over there. Let's look at our domain though. So where it's the furthest x, it looks like I start at 3, and I have a closed dot at 3. So my domain would be from 3, and then I keep going all the way to the positive x's. So I would go to positive infinity for my domain. My range, I start up here at 4. Notice I don't cross over on 4. So I'm going to start at 4, and then I'm going to keep rising up to my positive infinity y values. Now let's take a look at that cube root graph. So kind of like the function of square root, but this one has a little easier pattern to him. So I can have negatives in my square root, so I'm going to fill in my table kind of like this. I do 5 on the cube root just because I like to have a nice full graph, otherwise I get a little confused of where it's going to go. So I plug in my values here. Cube root of negative 2. Now if you need help trying to find that cube root on your calculator, call me over when we get to class. Say, Marsh, where's the cube root on this thing? I'll show you. Another way you could do this, you could do negative 2 to the 1/3 power. Because remember, you can always flip-flop your cube roots and your rational powers. If that helps you, by all means, do it that way if you want to be able to type that into your calculator. So, cube root of negative 2, that is the negative 1.26. Cube root of negative 1, well, that's just negative 1, because cube root of 1 or fourth root of 1, that's always just 1. Cube root of 0 is 0. Cube root of 1 is 1, and cube root of 2 is 1.26. Notice, guys, how this does a pattern. These are all the negatives, 0 positives. That will happen. You'll always notice that they'll kind of do that unless you're shifting it. Then it will not do it as nicely. My graph then, it's going to look something like this. Notice, it kind of has like a turnaround point right here at 0, 0. Then I have this negative 1, 1, negative 1, negative 1. And I got 1, 1, and then 2 kind of goes just a little bit above that, but not by much. My domain, notice I'm getting all the negative x values and all the positive x values. So my domain is negative infinity to infinity. My range, getting all the negative y's and the positive y's. So my range is that one as well. Now, how does this shifting look like for a cube root? Kind of the same thing for like we had for our square roots. We're going to start with our original vertical shift down, not a vertical shirt. So if I have a plus k or a plus a 3 or something on the outside, it's going to tell you if you're going to go up or down. H, if it's inside the cube root, that's going to tell you left or right. And just like last time, vertical stretch and reflection are going to do on the outside. So if I have a 1/3 on the outside, it's going to stretch my thing, make it a little more fuller. And then if I have a negative, it's going to flip it around, so it's going to look a little different. Let's do that with our 2 particular graphs here. So just like last time when we did our square roots, you want to make sure that you think about your shifting here. So x minus 2, remember that's going to make me right 2. It's going to go up 1. So that's going to be the turnaround point where normally 0, 0 would have been on our function. But since we're moving this guy around, we got to go right 2, up 1 to find out where that middle point is. So I'll go right 2, up 1. So my point in the middle of my graph will be 2, 1. So I'm going to fill in around him, give him some groupies. So I'm going to 1, 0, and 3, and 4. So then I plugged these guys in here, and I did cube root of 0 minus 2 plus 1. Well, cube root of 0 minus 2 plus 1, well, cube root of 2, right? Plus, or negative 2. Cube root of negative 2 plus 1. That would be negative 0.26, okay? Plugged in my 1, so I did 1 minus 2 plus 1. Well, cube root of 1 minus 2, that is just negative 1 inside here, right? Cube root of negative 1, that's negative 1, plus 1, 0. Plugged in the 2, got that for my thing already. Let's do my cube root of 3, plugging in the 3. So 3 minus 2, that is cube root of 1 plus 1. Cube root of 1, 1 plus 1, 2. Notice this one doesn't have as nice of a pattern. It's because we're moving it up and down. That's kind of why the pattern kind of is a little off. 4, so cube root 4 minus 2 plus 1. 4 minus 2, that's 2. Cube root of 2 plus 1 is 2.26. Let's graph this. So at 0, I'm going to go down 0.26. So kind of like right there. 1, 0 would be one of my points. 2, 1, and then 3, 2 is another point. And 4, 2.26. Right there. So I'm going to have a graph that's going to look something like that. Kind of looks like a cubic function laying on its side. If you kind of look at it, it's like a cubic function laying on its side. My domain, guys. So I got all my negative x's, positive x's. So it'll be, whoa, that was weird. Negative infinity to positive infinity, and my range is the same as well, because I'm getting all my negative y's and all of my positive y's.